Hello, dear students. So this is our another this lecture, or you can say that series of lectures that I was going to discuss, and we have discussed some of the lectures on these a set of differential equations which are basically homogeneous, right? So in classwork we have already discussed about one of the second order that homogeneous differential equation that's called the Bessel differential equation. And we have seen that because the singularity that Bessel differential equation has, that is regular singular point, right? So, but when we use that Frobenius method, so we are basically, so with the help of that Frobenius method, we should be able to get two linearly independent solutions, but that's not the case with this kind of differential equation, which is Bessel differential equation, and we have discussed it. And that was basically a kind of limitation of this series solution method, which is called the Frobenius method. Because the two solutions that we are getting for this Bessel differential equation, those are linearly dependent, right? So that was a kind of limitation to that Bessel differential equation, to this series solution method. And after that, in classwork, we have already discussed about what are basically the generating functions. As I already told you, those generating functions are basically, these are basically the encoded form of that series, this of a set of series that you have. So this is basically the encoded form of that. And you know that it is basically from the generating functions we should be able, because generating, it indicates that we are generating something from it, right? So we have this the general formula for this generating function is, that is this summation n starts from minus infinity to plus infinity j n of x t raised for n equal to e raised for x by 2 t minus 1 by t, right? And so from the generating function we should be able to get what is called that Bessel differential equation. That's why it's called generator or generating function. It basically generates that Bessel differential equation, right? And I cannot discuss much, because we have already done this kind of exercise in our classwork. So this is our generating function for this Bessel differential equation, and if you differentiate it, if you differentiate this equation with respect to that x, so you'll get this differential equation, this recurrence relation. Why it's called a recurrence relation? Because it tells you the relation between the different set of coefficients of genes, right? So that's why these are called a recurrence relation. That we should be able, we're getting the recurrence relation from the generating functions. So the second thing is that, so again, if you take this equation and you differentiate it with respect to t here, so we'll get this recurrence relation, right? So we can get two sets of recurrence relation. That is, this is recurrence relation first and this recurrence relation second. Okay. So from these two recurrence relation, you can get some more recurrence relation from here, right? So first, if you add these recurrence relations, so if you add equation first and equation second, so we'll get that, because this is jn of minus jn plus 1 and this is j of n plus 1, and तो ये cancel हो जाएंगे. So only on the right hand side हमारा क्या रहेगा, that is twice jn minus 1 of x, and on the left hand side we can have this plus this term, right? So that means we can have this twice that j dash of x plus 12 by x, because what I did here, I basically add these two relations, so that is twice j dash of x. So that is basically when you are differentiating this equation. And second is that plus, that is 12 by x j of x, that will be twice, because you are adding these two equations. So we'll get that. So after adding these two equations, you can write that adding first and second. Okay. So we get this will be equal to, right? Because this is 2ij of n minus 1 of x. Or you can write that okay. Or you can write this as okay. Or so you can further rewrite this equation as, or you can write this as x j dash of x So this is another recurrence relation because what I'm getting by putting different values of n here. So अगर n का value मैं different लूँगा तो you can get the different relation between those j's, because if you put that n equal to 0, so on the right hand side you can have j minus 1, on the left hand side you can have j2, n equal to 0 you can get j1 plus, and here it will be j0 x, right? So this is basically the relation between different j's. So that's what is called the recurrence relation or accretion relation. Now, so this is you are getting one more reconciliation when you add these equation first and second, right? So let's have a look again. तो अगर हम क्या करेंगे, if instead of that, अगर if instead of addition, if you subtract these two equations, right? So if you subtract these two equations, so you will get, because when you subtract this from this, so you will get that twice that 2 plus 1, because you are subtracting first from second, right? So when you subtract first from second, so on the right hand side you will get that is 2j plus 1 of x on the right hand side, and on the left hand side you will get that 2n by x j of x minus this, right? So that means when you subtract first from second, okay, so when you subtract first from second, you will get that twice okay, or you can rewrite this as, so because 2 will cancel on both sides and you multiply this x to these two terms, right? So you will get that. Let's check that. What's that? Jn plus 1 of x minus x jn dash of x. Because let's have a look on this whether it is correct. Right? So first is that is because 2 will cancel on the both sides, so it will be n by x jn plus 1 of x minus 2y jn dash of x, that's equal to j of n plus 1 of x, right? Now you do one thing, you just multiply this x on the both sides, or you can multiply this x to this. So it will be n jn plus 1 of x minus 2y jn dash of x minus that x jn dash of x equal to that's x jn plus 1. So this is what I did here. So I simply multiply that x on both sides, and that 2 will cancel throughout the equation. So this is again the one more reconciliation. So that I get from this by subtracting these equations first and second. So what basically I get from, if I differentiate my that generating function with respect to x and with respect to t. So from these two I'm getting two relations, then from these two equations, from these two relations, recurrence relations, by adding and subtracting I'm getting two more recurrence relations. So in general I can have four recurrence relations. So from that generating function. So in addition to that, so if you do one thing, suppose you multiply that equation. So because we have this equation, let us rewrite this third reconciliation. So our third reconciliation is that's x j dash of x. So let us rewrite this equation third. So is it third or yes? So this is reconciliation third. So let us rewrite equation third. So that means I can write that that's n j dash of x. So that's x j of n minus 1 of x minus that n j n minus 1 of x. Is it n minus 1? So what I did here? So this should be, sorry. So I did a mistake here. So because this should be here plus. This should be plus. So x j of n minus 1. X j n dash of x. So what I did here? So let's check whether it is correct. So this x j n dash of x plus x j n plus 1 of x equal to x j of n minus 1 of x, right? So let us rewrite that because I did a mistake somewhere. So So our relation is that is mjn of x. So that's equal to plus x. That's equal to. So let's check whether this is correct. That's xj of n. That's correct. Huh? This xj of n plus 1 of x. Is it xj of n plus 1 of x? Okay, so yes. Okay, so we can do one thing now because what was that relation? So I'm getting these two relations from here. Okay, that's right. So first, so when I add this, I'm getting this mjn of x plus xjn dash of x equal to xj of n minus 1 of x, right? There should be some way because let's check whether it's correct because when I add these two equations, so these two equations जब मैंने इनको add किया है, so I'm getting. So sorry, there is a mistake because when I add these two equations, this should be 2i dash of x plus 2n by x jn of x, right? So that was the mistake here. So this is so this is this thing, or you can write here x jn of x, right? It's not n plus 1. So I'm getting that n x jn of x plus n jn of x, right? That's equal to. Okay, that's correct. So okay, so that's this. Now what we'll do here, we just multiply by. So let's multiply it by. So we multiply it by x raised power n minus 1. तो इसको मैं multiply किससे करूँगा? X raised power n minus 1 से. Right? So this relation becomes. So inside is that's n j of x. So that's equal to. So when I multiply this x raised power n minus 1 to this, so it is x raised power 1. So it will be x raised power n. So x raised power n. Okay. Or this will be equal to. You can rewrite this as. So this will be equal to n jn of x. Right? So this is this. Okay. Because यहाँ पे मैंने क्या किया? I simply multiply by x raised power n minus 1 to this to the whole equation to this equation, and the first term becomes because it's n here, so n jn of x and it will be x raised power n minus 1, and now multiply this x raised power n minus 1 to second term. Right? So our second term is that's x times because it is x raised power n minus 1, it will be x raised power n here. Jn dash of x that's equal to on the right hand side you can have because you are multiplying by x raised power n minus 1. It's already that. We have already that x here, so it will be x raised power n jn of n minus 1. So let's have a look on the left hand side. So जो हमारा left hand side यहाँ पे है, so this is simply you can rewrite this as, so this will be d by dx of x raised power n jn of x, right? So because when you differentiate this, तो अगर मैं इसको solve करूँगा, I need to differentiate it with respect to x. So first differentiate to x raised power n, keeping this as constant using product rule. तो जब हम x raised power n की डिफरेंशिएशन निकालेंगे, it will be n x raised power n minus 1. So that is this term. So n x raised power n minus 1. तो ये हमारा ये पार्ट रह गया. When I differentiate this x raised power n, तो ये same रहेगा. That is jn of x will be same. So this is our first term from here. Second, when you keep this x raised power n as constant, differentiate the second term. So first term will be x raised power n and differentiate the second term, so it will be jn dash of x. So that is this term. So this will be equal to the right hand side, right? So that means I can write this as d by dx of because so this is simply, let's have a look. So because जो हमारा राइट हैंड लेफ्ट हैंड साइड है तो वो क्या होगा, so this will be d by dx of x raised power n j of x, so this will be x raised power n j n minus 1 of x, right? तो वही मैंने यहाँ पे भी लिखा, so this is our another reconciliation. And similarly we are basically, we already get the that fourth reconciliation by subtracting that equation first from equation second. So I'm getting one more, that is reconciliation number fourth, right? So let us rewrite that reconciliation, and we can get again by multiplying by some factor x raised power something, we can get another reconciliation. So I can explain later. So what we can get from here, right? So firstly, let us rewrite that equation. So let's rewrite equation 4. So what's equation 4 here? So equation 4 is, so what's it? So this is our equation 4, right? So this is our equation 4, right? So equation 4 is, that's x raised power x j of x, or okay, you can write this as x j n plus 1. तो यहाँ पे भी मैंने गलती की है, just have a look on this. So because when we subtract these, so I am getting, so it should be jn, sorry. So क्योंकि वहाँ पे भी मैंने गलती की थी. Okay, so you can write this as jn of x. So that is 2n by x jn of x. This will be this. Or you can write this as, so it will be again here j of x. Or this will be this. Okay. So this is our fourth reconciliation. That's rewrite. Okay, because this is a fourth reconciliation. Now you write this as okay, let me write this equation first. Okay, so let me write that. So that is, or you can write here. So why I'm writing this? So we can write that n j of that x. और यहाँ पे मैंने क्या किया, or you can rewrite, because if you write this first term here, that's x j n dash of x, then this it will be then minus. तो वही मैंने यहाँ पे भी लिखा. So what I wrote here, that is n j n of पहले, so second term this will be then minus. Right? So I basically, or you can write this term first, then so it will be then plus. Huh? Now you multiply this by. तो अब मैं क्या करूँगा? I will multiply this equation by x raised power minus n minus 1. This equation, right? So my equation becomes, on the right hand side, because we have this x raised power minus n minus 1, this x raised power 1. So it will be equal to minus x raised power minus n. Okay. Or you can write this as, this will be equal to, और यहाँ पे मैंने गलती की है, because this is, sorry, so what was there? Okay, let me first rewrite, because I did a mistake here. So this is n. Huh? So n j of x minus x. Huh? Now you multiply this as, so this will be equal to, it will be n x raised power minus n minus 1. तो just have a look on this. तो यहाँ पे मैंने क्या किया, I simply multiply by this x raised power minus n minus 1. तो उसको मैंने मल्टीप्लाई किया. सो ऑन आवर लेफ्ट हैंड साइड, तो लेफ्ट हैंड साइड से क्या होगा, तो दिस विल बी n x raised power minus n minus 1 jn of x minus that is multiplied that x to this term. So it will be x raised power minus n because it is x raised power plus n. So this will be this. तो अगर हम ये वाली टर्म देखें, तो ये वाली टर्म मैं लिख सकता हूँ, इसको मैं लिख सकता हूँ, तो दिस टर्म, दिस होल टर्म, राइट. तो इसको मैं लिख सकता हूँ, दैट इज डी बाई डी एक्स ऑफ x raised power minus n j of x. Okay, लिख सकता हूँ इसको, बिकॉज इफ यू evaluate this differential, d by dx of x raised power minus n. So take that x raised power minus n first part, differentiate this, it will be minus n, or you can write this as, because so what I did here, okay, so this will be equal to, or you can multiply that minus on both sides, so this will be minus nx raised power, अगर मैं इसको multiply both sides minus n से करूँगा, so this will be equal to minus n x raised power minus n minus 1 jn of x, and second term will be, that will be plus x raised power minus n, right? Because if you multiply it by minus term, so then this will be equal to, it will be, if you write this as minus, so this will be plus and this will be plus, right? तो ये क्या आएगा, माइनस n x raised power n minus 1 jn of x, then second term will be x raised power minus n jn dash of x. So this is this, and our right hand side it will be x raised power minus n jn of n plus 1 of x, right? So that means we can have one more relation, that is d by dx of right. So that will be equal to, so this one, 6 reconciliation, because we have almost 6 reconciliation and we can get some more reconciliation. So but before that, so let's evaluate some of the things, because we have already from first reconciliation we can see what's the relation between j0 and j2, right? So first, so from this reconciliation, first, so what is first reconciliation, that is always that j and dash of x, so that's equal to j minus 1 of x. So is it, sorry, so I need to check that what is that relation. The first reconciliation is, that is y j and dash of x, y j and dash of x, that's equal to j n minus 1 of x plus, right? Okay. Now if you put n equal to 0 here, so put n equal to 0, so you can get that y j0 dash of x. Okay. Because we know that this j minus 1 of x, so this I can write as, because we know that j minus n of x equal to minus 1 is for n j n of x, but n is 1 here, right? तो अगर मैं यहाँ पे what is of j minus 1 of x, so that will be equal to minus 1 raised power 1 j1 of x, so that's equal to minus j1 of x, right? So let's use it here, because j minus 1 of x will be minus j1 of x, right? So we can rewrite this as, that is j0 dash of x, that is twice, so that's equal to minus j1 of x. So that means j0 dash of x will be equal to So we can verify that because we know that. So if you see that, so we have already calculated, if you plot that j of x as a function of that x, so you can see the different values of those j's, right? Because that if this is 1 here, so this is, so this corresponds to our j0 of x, and our j1 of x is that sine curve. So we have already calculated, so this is our j1 of x, and similarly if you calculate that j2 of x, so it will be little bit steep, so it will be that j2 of x, and similarly if you go for j3 of x, so it will be little bit down, so this will be our j2 of x. So there is damping. When you increase the value of n, so it gets these j's gets dampened, right? By increasing the value of n, right? So that means you can check here because j0 of x is our this one. So this is our cosine. You are basically getting the cosine term when you write that, because jn of x is that. So if you write that jn of x, because that was some summation n starts from 0 to infinity minus 1 is for j upon j factorial n plus j factorial x by 2 raised power 2j plus, right? तो यहाँ पे जब मैं सबस्टिट्यूट n का जीरो वैल्यू करूंगा, so I'm getting j0 of x as a cosine function. So cosine function is this thing because it has maximum value at x equal to zero, right? So this is the origin here, right? So what I'm saying here, I'm basically telling you the significance of those generative functions because I should get those all those relations are the different values of that j that I'm getting from the Bessel function, right? Because I'm writing this is the encoded form of that this series method, right? So which is basically for this Bessel differential equation. Now, second thing is that if you differentiate this, so you will get that when you differentiate the j0 dash of x, so which is cosine, and you differentiate it, so you will get the j1 of x. So that's this thing, but the phase will be opposite because our that j0 dash of x is equal to minus j1 of x, right? So this was this was one of the importance of those these generative functions, how we are getting the different those recurrence relations, right? And one more thing is that if you want to calculate the higher values of the j, because we have already calculated what is j plus half and j minus half, right? Because we know that, so our j 1 by 2 of x is equal to, that is square root of 2 by pi x. So this is basically when we evaluate that. तो जब हम ये इवॉल्वेट करेंगे द jn of x by putting that n value 1 by 2, तो j half and what is j plus half and j minus half, right? So I'm getting those. So that is square root of 2 by pi x sin x, and that's square j of minus half x is equal to square root 2 by pi x into cos x, right? We have already done it in our during our class work. And if you want to calculate the higher values of j also, right? And you can see their behavior. If you plot that j of x as a function of x, so you can see their behavior, how they behave, right? Second thing is that, so if you want to calculate what is j3, तो अगर हमें कैलकुलेट करना होगा what is our j3 by 2 of x. So this is basically this, or you can directly calculate from the reconciliation from this Bessel function. यहाँ से भी हमें calculate कर सकता हूँ by putting n equal to 3 by 2, or you can see the importance of those reconciliation because we have already calculated the 6 reconciliations by differentiating that our generating function with respect to x and t. Then we add and subtract, and we multiply by some factor x raised power n minus 1, and getting fifth reconciliation, and also multiplying that those subtracted equation by x raised power minus n minus 1, we are getting the sixth these reconciliation. So there are many other reconciliation we can discuss in future, or if it is not possible, I can show you how to do that, right? Now, so this is one of the significance of these reconciliation, to how to get the higher values of that g. So first, let's have a look on this first reconciliation. So first reconciliation is that is jn of njn of x, njn of x. We know that. We know. mj of x will be equal to, okay, because so this is which relation? So let us have a look on this. Okay, this one, right? Because when you differentiate this, you are getting first relation recurrence means that is j dash of x will be equal to j of n minus 1 of x, not this one. So we need to deal with this one because when you multiply, that's m j of x will be equal to x raised power n. So this is what basically I wrote here. That's m j of x will be equal to, that's x raised power that j of n minus 1 of x plus x raised power j of n plus 1 of x, right? Now again, we have because we already know what is j half and j minus half, right? So simply substitute value of n equal to 1 by 2, right? So if you put that n equal to, so this will be equal to, okay, or this will be equal to, okay, right. Because putting that n equal to 1 by 2, so you get j 1 by 2, j minus 1 by 2, j 3 by 2, right? Because we know that what is j 1 by 2 and j minus 1 by 2, right? So we can write that what's our j 3 by 2. So from here we can write that is j 3 by 2. So that will be equal to, so I did a mistake here, sorry. So I did a mistake here because this was that 2n, huh? 2n, that's what. So you write that, so this will be here, this will be 2 here. So you can erase this thing because this will be 1 here, huh? And on the right hand side you can write this as x j half, okay. Okay, that's it, minus x j, right? Or you can write that j 3 by 2 of x is equal to, okay. Now we already know that what is j plus half and j minus half. So j plus half is square root of 2 by pi x sin x, and this will be cos of x, right? So let's rewrite this as, so it will be 1 by x square root of, this will be equal to, so first is that is this is j 3 by 2 of x, huh? So j 3 by 2 of x, that is square root of 2 by pi x, that's sin x by x minus cos x. Similarly हम क्या करेंगे अब, so we'll put now that here in this equation, that's 2n or 2n by x equal to this thing, so put n equal to now minus 1 by 2. तो वही मैंने किया यहाँ पे, By putting n equal to minus 1 by 2, you'll get j minus 3 by 2 of x will be equal to this, right? So that means by doing this, because now we have calculated what is j 3 by 2 and what is j minus 3 by 2. We can calculate j 5 by 2, j minus 5 by 2, j 7 by 2, j minus 7 by 2, right? So that means you can get higher values for these j's, right? So we can now, so instead of that, you can also write that, if you write that n equal to 1 by 2 in this relation, because you can write here, because we know that d by dx now that equal to x h bar, right? So we can also use this and to get the different values of j, right? Or you can write that what is j 5 by 2, j minus 5 by 2, j 7 by 2, and what is j minus 7 by 2. So that means you can get the higher values of the j. Yeah? And in our next lecture, we are going to discuss some. So if some function satisfies this recurrence relation for this Bessel differential equation, that will be the solution of that Bessel differential equation, and we can get some that which is what's called orthogonality condition from this, because this is a boundary value problem as per this Sturm-Liouville's theorem demands. Sturm-Liouville's problem demands, right? So if it satisfies that condition, so then we can say that we can construct a set of orthogonal functions for that kind of differential equation, right? So hope you got this lecture. So in our next lecture, we are going to discuss some more things related to this Bessel differential equation. Thank you very much.